Good morning and once again welcome to my YouTube channel Maths with Is by Mr. Kamotho, and in this video we are going to explain a question that is going to conclude our number 7, a question in exam practice number 7, question number 4, and it is telling us show 3 point, there's a decimal point here, 3.xy, and the dot is upon x and y. That means the two of them are recurring, is equals to xy plus 297 and everything over 99. And this is a question of recurring decimals, which is equivalent to the right hand side. And our duty or responsibility is just to try and express the recurring decimal part as a fraction, because the right hand side is of course in fraction form, and therefore allow me to call 3.xy recurring, this time not x but p. The reason why I'm not going to call it x is because within it we have x, so we might get confused which x are we talking about. So let's have p is equals to 3.xyxy. Moving forward, if we go to 10p, we're going to have 3x.yxy. If we go to 100p, we are going to have 3xy.xyxy. And I want to explain this part. We said anytime we are having a recurring decimal and we are interested in writing it as a fraction, we must keep multiplying the original number by multiples of 10 until we have two numbers which are identical after the decimal point. So the first number, which is p, which happens to be our original number, is 3.xyxy. If you look at what we have now, 100p is 3xy.xyxy. So this part and this part are identical. So we have to deal with this in an attempt to look for their differences. So 100p minus p, which is equivalent to 3xy.xyxy minus 3.xyxy, and the difference is after the decimal point. Since we have identical values, we have 0 there. But look on the left of the decimal point. What is most important here is the place value of y is the same as the place value of 3, because those are ones. The place value of x, it is in the tens position, and 3 is in the hundredth position. So we have something that we are going to have 3x, or rather we have y minus 3, because that's the difference. Y minus 3, we have something. X minus, there is nothing here, we have x. 3 minus, we have nothing here, we have 3x into bracket y minus 3. And this is 99p is equals to that, because 100p minus p is 99p. So remember very well and so clearly that these are ones, these are ones, these are tens, it is in the tens position, and these 3 is in the hundred position. So if we were now to rewrite them differently, we're going to have 99p is 3, the value of this now. 3 times 100 is 300 plus x is in the tens, 10x. All right. That is 3. Okay, plus y minus 3 times 1. They are in the ones position. And what we have here is, if you may want to open this bracket, we're going to have 99p is equals to 300 plus 10x plus 10x plus y minus 3. These are already in ones position, so both of them are together in ones. So what are we simply saying? What are we simply saying? So in other words, what we have is now dividing both sides by 99. But before we even get there, there is something which is emerging. For example, if you continue to have 99p is equals to 300 plus 10x plus y minus 3, after we open this bracket, now we can take the like terms here and see 300 minus 3 is obviously 297. So 99p is equals to, look at the x in the tens position and y in the ones position. So we can combine the two and have xy, because already y is in the ones place value and x is in the tens place, is in the tens place value. So we can have xy. Of course, x is in the tens, y is in the ones. And 300 minus 3, we have plus 297. That is it. At this point now, we can have to divide both sides by 99, and we are going to have our P, or our final submission to this question, is xy plus 297 all over 99. And that is exactly what we were to show. Hence shown. Hence shown. There we are. This is a serious question. Please follow and let us ask questions, and subscribe, share, and of course comment. Thank you.